We're going to talk about a process we use to construct composite parts like decks, deck hatches, and even three-dimensional parts such as engine covers and even the full lamination of hulls. And that process is called vacuum infusion or resin infusion. I've been working with vacuum infusion process all the way back to the time when most boat manufacturers had never even heard of the term.
Yeah, we should have cut the flow medium back a lot more on this. I don't know why we carried it right, and you would have ended up damming it a little bit more in these corners.
The origin of vacuum infusion started in the early 90s when the scrimp technology patent was coming to an end. This process was used to construct aeronautic parts as well as secret vessels for, well, you know who, the United States military. Scrimp technology was invented by this guy, Bill Seaman, as a means to meet the demanding requirements of the projects for the U.S. Navy. Like its now stepbrother, vacuum infusion, it's suited to build large-scale structural composite parts where high strength, durability, and lightweight are very crucial. I was lucky to meet early on two gentlemen who were innovators in the vacuum infusion process and in the manufacturing of epoxy resin. That with a simple change in hardener can be used as an infusion resin. The name of that product was Maz Epoxies. One of those guys was Tony DeMilla. The other one was J.B. Carell, who's a good friend of mine still to this day. Anyone who's anyone in the marine industry knows JB and the many companies and manufacturers that he has either owned or been involved with their innovation. Tony invited me down to his laboratory. It's got to be 25 years ago where he showed me the process of vacuum infusion. Right here, 25 years later, this is the very first hatch that I infused. We used either foam composite or marine grade plywood for core material. We drilled a series of holes, 2 inches on center, perforating the core for the resin channels to transfer the resin through the core, laminating the fiberglass on both sides at the same time. We dial in the fiberglass to resin ratio better than any hand layup could ever conceive. Back then, it wasn't as easy getting these so-called infusion materials. We used to buy our flow medium from a manufacturing company that made the produce netted bags. We'd use that material as our flow medium. Until we were able to buy plastic bagging material in volumes, we would buy it from the same company that manufactured oven bags. Like the bags used in the old days with shake and bake. Over the last 25 years, the method has stayed the same. However, the process, the equipment, and most importantly, the materials have changed drastically, both with advancements as well as availability, making it easier for us to tackle bigger infused parts, like our own new boats. With today's unlimited amount of supplies readily at our hands, we're able to infuse 30-foot decks with the confidence of creating strong, lightweight, 100% solid composite parts. Clancy's boat was the second deck that we vacuum infused. Back then, unable to get very wide rolls of plastic, we vacuum infused the deck in 2 sections. To construct the deck, we use 1-inch, 4-pound density foam, doubled up in crucial areas to 2 inches, wrapped in 5 layers of 1708. We then vacuum infused 1 section at a time, fiberglassing them into 1 part after we glued them in place to our prepared stringer system. You'll notice the aluminum plate grid system on the top of our stringers. We've been incorporating this aluminum grid into our Seacraft restorations for a long time. And to this day, we use aluminum along with other composites like G10 and Penske board into our stringer systems for both restorations and new boat build. The aluminum and tappable composites such as G10 allows us to be able to drill through the deck and mechanically fasten the above deck components such as the console, leaning post, and T-tops, ensuring that these components are now tied, mechanically bonded directly into the structure of the vessel. Throughout the remanufacturing process, you'll notice the many upgrades in the structural build from the original design, further giving us the confidence and knowledge that these boats that have been around for 40 years will be around even longer the second time around. Well, actually, you'll be able to see the benefits of our structural processes when we get into the refit process of JB in our next upcoming episodes. But for now, we're going to take another break, and when we return, we're going to get into the core replacement process to the gunnel cap, where we don't use vacuum infusion, but we use another process called vacuum bag. So see you when we get back.
If you like this segment, click right here. If you like this segment and you want to watch the whole episode, click right here.